This video covers everything we did in class today in 8th grade honors math on November 18th. Make sure that you have ClassKick open so you can follow along with this video. The first thing you need to do is take care of the do now on slide 1, so go ahead and pause this video until you've got the do now completed. Okay, so you might notice that we've got 5 ratios here, and we can calculate the unit rate in multiple directions. For example, we could divide 40 by 5, which equals 8, and tells us that A has a unit rate of 8. But we also could have divided 5 by 40. For every relationship, we have 2 unit rates, because there are 2 quantities that we can divide by one another. 40 over 5 has a unit rate of 8, because 40 divided by 8 equals 5. We know that 24 divided by 16 and 16 divided by 24, neither of those is equal to 5, or to 8. Got mixed up here. 40 divided by 5 is 8. What about 96 divided by 12? Well, yeah, 96 divided by 12 equals 8, so we know that this ratio has a unit rate of 8. And I see one more option there. You guys know what it is? 48 divided by 6 also equals 8. And so these 3 ratios all have a unit rate of 8. Now, if the ratios were reversed, like it was 6 to 48, we could still say there was a unit rate of 8, because every ratio has a unit rate in multiple directions. So for example, for ratio D, 6 divided by 48, or 1 over 8, would be the other unit rate. So go ahead and make sure you have question 2 answered, and that your answers are labeled. You want to be dividing the cost per pound to find the cost of strawberries. We're not going to go over this one in the video. Today's learning target is I can decide whether a point is on a line by finding quotients of horizontal and vertical distances. You got a pretty straightforward lesson today. We're just going to do lesson 11. There is an exit ticket in the main folder. There's no new homework tonight, but make sure you're caught up for the week. And remember, you can always see that list at the top of Schoology. So activity 11.1 says, let's explore the relationship between points on a line and slope of the line. Find each of the following and explain your reasoning. The length of segment BE and the coordinates of E. Notice that we have a similar figure here, and we know it's similar because it shares a hypotenuse. The 2 triangles share that hypotenuse side. And so we can determine the length of side BE by determining the length of the other sides. So I know that the length of AB, for example, is 2 units, because the distance between 0, 2 and 2, 2 is 2. And I know that the length of AC, so from here to here, is 4 units. And so right away I can tell what my scale factor is, right? My scale factor is 2, because AB to AC doubled. From C to D is 5 units. And so that should tell you what you need to know now to find EB. So go ahead and pause this video and try to answer questions 1 and 2. So you should have noticed that BE is 2.5, and the reason is that the scale factor between triangle ABD and triangle ABE is 2. And so 2.5 is half of 5. And that means that the coordinates of E need to be 2.5 higher than B, right? Because the distance between B and E is 2.5. And so the coordinates, the X value stays the same, but the Y is 4.5 because we added 2 to the Y value. Now, on slide 4, line J is shown on the coordinate plane, and line J is this entire line. It says, what are the coordinates of B and D? Is the point 2015 on line J? Is the point 175 on line J? And is the point 9068 on line J? I want you to go ahead and pause this video and give 11.2 a try. Okay, so you should have been able to label the coordinates of point B and point D. We can see that the coordinates of point B are 4, 3, and the coordinates of D are 8, 6. Now, notice that we have a pattern happening between our x coordinates and our y coordinates, right? 4 times 2 is 8, and 3 times 2 is 6. They are proportionally related with a scale factor of 2. And so we know that the point 20, 15 is on the line, and here's why. If you can imagine the coordinate pair 4, 3, and compare it to the coordinate pair 20, 15, the same pattern that we can kind of see between 4, 3 and 8, 6 exists here, in the sense that we can multiply 4 times 5 to get 20 and 3 times 5 to get 15. And so the reason why 20, 15 is on the line is because the x and y values are proportionally related. There is a scale factor, right? And so you want to investigate whether or not that's true for the other options. In question 3, you're comparing 4, 3 and 175. And of course, you didn't have to use 4, 3. You could have also used 8, 6 to compare. But then in question 4, you would be comparing 4, 3, or any of the other coordinates you know to 90, 86. So if you need another second to make sure that you've got those answers to questions 3 and 4, you can pause the video again. And then for question 5, I want you to just go ahead and summarize what we've talked about. I'd like you to write a rule that would allow you to test whether the line is on point J. So you could write that as a sentence, right? To test whether a point is on line J, we can always what? Go ahead and complete the sentence to finish slide 4 and come back for slide 5 when you're ready. (11.3) says here are 2 diagrams. Complete each diagram so that all vertical and horizontal segments have expressions for their lengths. I want you to go ahead and pause the video and just answer question 1. We'll go over question 2 together.